Hello guys, welcome everyone. I hope the voice is clear. Yeah, so let us see now few questions, previous year's questions based on work done. Yeah, yes, is going on, signal is good. Let me check once whether the streaming is okay or not. Right, let's see a few questions based on work done. Work done. So here the questions based on work done means work done by constant force, work done by variable force, graphical based questions. All together, let us discuss. Yeah. So one of the question is from 2019. This question is asked in 2019. So yeah, just a second. Let's see. Why is the streaming is not started? Just a second, guys. Yes, guys. So the question is. So write down the question quickly once. A force F is equal to a force F is equal to 20 plus 10y. 20 plus 10y acts on a particle in y direction. Acts on a particle in y direction. In y direction, where F is in Newton and y is in meter. Where F is in Newton and y is in meter. Full stop. Meter. Work done by this force to move the particle. Work done by this force. Work done by this force to move the particle. To move the particle from y equal to 0, from y equal to 0 to y equal to 1, to y is equal to 1 meter is. So it is a neat question. Neat 2019 question. Right, let us see how to do it quickly, and you can mark down the options as well. First option says 5 joule, second option says 25 joule, third option says 20 joule, fourth option says 30 joule. Right, yeah, work done by the given force. So as it is given that F is equal to 20 plus 10y, and as y changes, F changes. So the force is a variable force. Force is a variable force. Given F is equal to 20 plus 10y or 10y plus 20. So then work done by variable force can be work done by variable force is given by integral of f dx. If it is moving along x-axis, if it is moving along y-axis, so we can write f dy. So it is equal to integral of f is 10y plus 20 to dy, where y goes from 0 to 1. So it is equal to 10y can be expressed as 10 into y square by 2, y square by 2. Limits are from 0 to 1, so limits of y are from 0 to 1, and plus 20 dy is 20y. So again for y limits are from 0 to 1, so it is equal to 10 by 2 is 5, so you can write 5, y place if you put 1 square is 1, 5 plus y is going from 0 to 1, so 2 into 1 minus 0 is 1, so 2 plus 2, so it is equal to yeah, you can take it properly. Oh sorry, 20y, so 10y plus 20 here, right? So this is 20. We did a small mistake here. You can cross check this once. Correct it. 20 into y. Yeah. So this is 5 plus 20. So therefore it is equal to 25 joule. So second option is the right one. Right. So this is how you can do questions really quickly. Next question. Yeah. Next question. Yes. So it is 2016 question. 2016 question. Question is, a particle moves from a point I hope the streaming is going on. What happened? It's not showing only. Let me check the streaming once, guys. The streaming is not happening. Yes. Yeah, it's coming. One sec. Yes, guys. So the next question. Yes, it is a 2016 question. The question is, a particle moves from a particle moves from a point minus 2I cap plus 5j cap to 4j cap plus 3k cap when a force of 4I cap plus j cap 4I cap plus j cap Newton is applied on it. Is applied. How much work has been done by the force? How much work has been done by the force? Options. First option 8 joule. Second option 11 joule. Third 5 joule. Fourth 2 joule. Yeah. So it is given that the particle has moved from one position with the position vector is given. Initial position vector is, so how to do this kind of questions. Let us say initial position vector, we can take it as Ri bar or R1 bar, either way you can write. Okay, R1 bar is equal to minus 2I cap plus 5j cap, initial position vector. And final position vector, you can take it as R2 bar is equal to 4j cap plus 3k cap. Okay, so the displacement vector is given as S bar displacement is equal to R2 bar minus R1 bar R delta R bar. So R2 bar minus R1 bar is 4j minus 5j, so minus j cap. 3k, there is no k term here, so k term is 0. If you take the I term is minus, so you can rewrite like this with the I terms first. So 2I cap minus j cap plus 3k cap will be displacement vector. Okay, R2 bar minus R1 bar. This minus this, if you do, you will get this one. And force vector is given as 4I cap plus 3j cap Newton. 4I cap plus 3j cap Newton is the force. Then what is the work done by this force is the question. So as force is constant, you can say work done W is equal to F bar dot S bar. As a shortcut, you can write Fx Sx plus Fy Sy plus Fz Sz, right? So this is equal to Fx Sx. Here x terms, and F is having I component, J component, K component. K component is 0. So X components or I components are 2 and 4. So 2 into 4 is 8. Then J components or Y components are minus 1 of S and 3 of F. So it is 3 into minus 1 is minus 3. Z component of F is 0. So you can say plus 0. So 8 minus 3 is equal to 5. So the work done is 5 joule is the work done. Is the work done. This is 2016 question, guys. Next, quickly. another question. Right, let us discuss one more question, like few more from previous year's questions, so that you can understand whether the whether you are able to do these questions or not, work-based questions. So again, if you see 2013, exactly similar kind of question is asked. I'll give you the question. You guys can try quickly. Just a second. I'll give you the question. Right. The question is 2013 question. It is a uniform force of a uniform force of 3i plus j 3i cap plus j cap Newton acts on a particle acts on a particle of mass 2 kg of mass 2 kg. Hence the particle is displaced. Hence the particle of right, I think I have to use some speakers if the voice is not that clear. Let me check. Yeah. So hence the particle is displaced from position yeah from position 2i plus k 2i cap plus k cap meter to position 4i cap plus 3j cap minus k cap meter. Then the work done by the force on the particle is, then the work done by the force on the particle is, right, options. The first option is yeah 9 joule. Second option is 13 joule. Third option is 6 joule. Fourth option is 15 joule. Right. So similar method. So work done is F bar at S bar, but S bar you have to calculate. As we know, work done is equal to, in vector form, F bar dot S bar. Okay, you can take it as equation 1 quickly if you want. You can take S bar is equal to, how to do in 1 minute? Directly you can take S bar is equal to R2 bar minus R1 bar, as R2 bar is final position vector is 4 I cap plus 3j minus k is the final vector minus initial position vector is 2i plus k minus half. If you simplify this, you will get 4i minus 2i 4i minus 2i right 4i. I think now voice is clear. Just I'm checking once. Yes, 4i minus 2i is 2i. 3j minus here j component is 0, so plus 3j minus k is k component becomes 0, so this will be the displacement vector. So force vector is given directly. This implies work done double is equal to, directly you can take fx sx plus fy sy plus fz is z. As a force vector, if you observe, given, you can take here, given f bar is equal to what, uniform force of 3i plus j 3i plus j Newton is acting. So x components product is 3 into 2 6 plus y components product is 3 into 1 3 plus z components product is 0, so it is equal to 9 joule. Work done is equal to 9 joule. So here in the options, first option is the right one, 9 joule. Right, so let us do quickly one more question, actually graph based question. Let us do one graph based question. Sorry. Yes, the question is from 2011. The question is, a force on a particle moving in a straight line, the force on a particle moving in a straight line varies with the distance d, varies with guys, the voice is clear now. Right, I think the volume from your side also, just you guys have to increase a little bit. Yeah. The force on a particle moving in a straight line varies with the distance d, as shown in figure. Yes, I'll give you the figure. Then the work done on the particle, the work done on the particle, during its displacement of 12 meters, during its displacement, its 12 meter is options. First option 21 joule. First note down the graph, then you can note down the options. The graph is this. This is distance d in meter on x-axis. On y-axis I have taken force F in Newton. So here it is taken as 0, 1, 2. So at d equal to 0, a force of 2 Newton started, no. When at d equal to 0 position, no force acts. According to the graph, no force acts, as the force F on the particle moving in a straight line varies with the distance. Here till 3 meter position, no force acts. Then a force of 2 Newton acts till 7 meter position, a constant force of 7. Then the force decreases to 0 at 12 meter position, right? Is the given data. Then what is the work done? Right. So here you have to remember that whenever force displacement graph is given, the work done is given by area under Fs graph, or force displacement graph gives work done. So note down the options also here. The first option says 21 joule. Second option says work done will be 26 joule. Third option says the work done should be 13 joule. Fourth option says the work done will be 18 joule. Right. So note down, the work done is equal to area under force displacement graph. Work done is equal to area under Fs graph. Here S is displacement is d, Fd graph, right? Now, so here if you observe the area, if you mark this is something like A, B, C, D, E. So here ABCD is a rectangle and DCE is a triangle. So area of rectangle ABCD plus area of triangle CDE also you can take. You can split into two sections and you can take the area of two things. This is one part is a rectangle, so first part, and this you can take it as a triangle, second part. So it is equal to area under FD graph. Work done is equal to area under FD graph. It is equal to area of rectangle ABCD plus area of triangle CDE. Right. So as you know, area of rectangle is length into breadth. Here in place of length you have you can take that the distance part is 7 minus 3 into you can say the breadth, this breadth length part is AB is 2 minus 0 is 2, so we can take 2 into 7 minus 3, or 7 minus 3 into 2 is area of rectangle. Plus area of triangle is half into base into height. Base part is 12 minus 7, right? 12 minus 7. Height is 2. Height is 2 units only, right? Yes, if you simplify this, you will get 7 minus 3 is 4. 4 into 2 is 8. Plus here is 2 cancel. 12 minus 7. 12 minus 7 is 5. Yeah. Very good. So it is 13. So therefore work done is equal to, work done W is equal to 13 joule. So how to find area under graph? You have to choose based on the shape of the graph. Based on the shape of the graph you have to choose. Right. I hope you have understand this. Next, one more question. It is from 2006. So it is a very nice question. You see here, the last question. With this I will stop it. We'll discuss few questions in the next session. Maybe next session we'll try to focus on work energy theorem based questions. Right, it is from 2006 question. 2006, but very nice question. As the question is 300 joule of work, 300 joule of work is done in sliding, is done in sliding a 2 kg block, a 2 kg block up an inclined plane, up an inclined plane of height 10 meter, full stop. Taking G is equal to 10 meter per second square. Work done against friction is right. Options: first option 200 joule, second option 100 joule, third option 1000 joule, fourth option 0 joule or 0. Yeah, so how to understand this? Try to draw a pictorial representation for the given data, then you will understand a little more clearly. So what is given is there is an inclined surface. This is an inclined surface, let us say, and the angle of inclination is theta. Let us say angle of inclination is theta, and it is given that there is a block of 2 kg. There is a block of mass m is equal to 2 kg is lying on it. Actually, a 300 joule of work is done in sliding this up the inclined plane. Okay, how much? 300 joule of work is done in sliding this up. Okay, then up the inclined plane, so that the height of this inclined plane is, so from here, let us say you have taken this to here. So the height of this is h is equal to 10 meter. H is equal to 10 meter. Now the question here is, what is the work done against friction? What we have to understand is, when the block is moving up, the friction force will act downwards. One point. Another point is, you have to understand that because of mass, if this is m is 2 kg, if it is mg will act vertically downwards, a normal reaction acts normal to the surface. And if extend this by symmetry, this will be theta, so mg cos theta will act here, and mg sin theta will act in this direction. Mg sin theta will act down the inclined plane. When it is moving up, frictional force and mg sin theta both will act downwards, down the inclined plane. But what we are asked to find? Work done by friction. So what you can say is, in moving up, the total work done, the total work we are doing is equal to it should be equal to sum of the work done by this gravitational force mg sin theta plus frictional force. So you can say work done by net force is equal to work done by gravitational force plus work done by frictional force. But you are asked to find what is this. Work done by frictional force is what is the question. Okay, so you can say this implies work done by frictional force is equal to work done by net force minus work done by gravitational force. Work done by net force is given how much? 300 joule. 300 joule, and so minus work done by gravitational force. Work done by gravitational force is, you can write here, is equal to gravitational force into displacement. Displacement right? Displacement in this case, when it is moving from initial point of this, from if you say this is point A, this is point B, so the actually in vertical direction displacement, you have to take this as a vertical displacement, that is nothing but height. So mg is a gravitational force, and actually for vertical displacement, what the gravitational force acting in vertical direction is mg, and h is the displacement. So you can take it as mgh. So therefore it is here minus mgh. If you substitute these values, you will get 300 minus, what is the mass? Mass is 2 kg. 2, g is 10, h is also 10, so 200. 300 minus 200 is 100. Therefore work done by frictional force is 100 joule. Therefore work done against friction or by frictional force is 300 minus 200 is equal to 100 joule. For it is equal to 100 joule. I hope you got it clearly. Yes, with this I am stopping the session. Right, actually there are a few more questions are there based on this work done. 2006 itself, one more question is asked. We can try a few other questions later on. Even graph based question in 2005 also one question is asked. Right, so let me give you that question, and then I will stop. One more question, graph based question I will give. Right, this is the question is, it is a 2005 question. 2005 question. A force F acting on an object, a force F acting on an object varies with the distance x, varies with distance x as shown in figure, full stop. The force is in Newton and x is in meter. The force is in Newton and x is in meter. Is in meter. The work done by the force in moving the object from the work done by the force in moving the object from x equal to 0 to x is equal to 6 meter is. First note down the graph, then the options. Graph, yeah, you can take, yeah, this is this is a graph. So this is so this is y-axis and this is x-axis. It is 0 and it is given that 0 1 2 3 4 5 6 7 3 4, okay, 1 2 3 4 5 6. Try to write down this calibration also properly. calibration of the marking of these numbers is called calibration. Okay, marking of these numbers on the x-axis is called calibration. So 1 2 3 4 5 6 7, yeah, and on y-axis 1 2 3 0 1 2 3 1 2 3. So at x is equal to 0, the force is 3 Newton force is acting and is continuously acting till x is equal to 3 meters. A constant force of 3 Newton is acting till x is equal to 3 meters. Then the force is started decreasing and becomes 0 at x is equal to 6 meters. This is x taken in meters and this is F force taken in Newton. Now, so we are asked to define what is the work done. What is the work done in taking the object from 0 to 6 meters till here? So same, so write down the options. First option 4.5 Newton, sorry, joule work done. Second one 13.5 joule. Third one 9 joule. Fourth one 18 joule. Right. So work done in FS force displacement graph, you know, work done W is equal to area under Fx graph, force displacement graph. Here displacement is x, Fx graph. So you can again here also you can divide this into two, what do you call, shapes. The first one into rectangle, second one into triangle. So for the simplest form, okay, simplest part, so you can mark this as O A B, okay, C D. So OABD is a triangle. Area of Fx graph you can mark it as it is equal to area of rectangle, OABD. This part you can mark it as this is OABD is rectangle and BDC is a triangle. So you can mark this as plus area of triangle BCD. So area of rectangle is length into breadth. You can take 3 minus 0 is 3 into 3 minus again height is length and breadth. If you take, oh, it is a square, not rectangle, square guys. So this side is say 3, this is side 3. So kind of units if you take 3 3, but it is one is force, another is position. Okay, so we have to take it as area of if one side having larger value than other, they can call it as rectangle. Area of a square OABD. Right. Now 3 into 3, this is 3, and this is also 3. So 3 minus 0 is 3, 3 minus 0 is 3. So 3 into 3 plus area of a triangle. Triangle BCD is half into base into height. Half into base is 6 minus 3. So it is 3. Height is of course 3. So it is equal to 3 into 3 9 plus 3 into 3 by 2. 9 by 2 is 4.5. It is equal to 13.5 joule. 13.5 joule. Right, that's it. So I hope all these questions you guys have understood. So these are all previous year's questions. If you are able to do these questions, means yes, you are in the proper track. So if anywhere if you are not able to do, try to go through the concept once and try. Yes, I hope you're all doing fine properly. Yes, take care, bye bye till we meet in the next session.